Welcome to my Luminary Profiles YouTube channel. In the tapestry of scientific brilliance, the life of Sir Isaac Newton stands as a testament to the unyielding pursuit of knowledge and the boundless wonders of the human mind. Born on January 4, 1643, in Woolsthorpe, Lincolnshire, England, Newton's journey unfolded against the backdrop of a world transitioning from the Renaissance to the scientific revolution. From humble beginnings emerged a prodigious intellect. Orphaned at an early age, Newton's formative years were marked by resilience and an insatiable curiosity. His thirst for knowledge led him to Cambridge University, where he immersed himself in the realms of mathematics, physics, and astronomy. The turning point in Newton's life occurred during the plague years of 1665 to 1666, when the university temporarily closed, and he retreated to his family estate in Woolsthorpe. It was during this solitary interlude that the seeds of his groundbreaking theories germinated. In what became known as his annus mirabilis, or miracle year, Newton delved into profound contemplations that would reshape the very fabric of science. The crowning achievement of this period was the development of calculus, an intellectual feat shared with the German mathematician Gottfried Wilhelm Leibniz. Simultaneously, Newton unraveled the mysteries of light and color through his experiments with prisms, laying the foundation for his revolutionary work, optics. Newton's magnum opus, Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, published in 1687, remains a cornerstone of scientific thought. In it, he elucidated the laws of motion and the universal law of gravitation, unifying terrestrial and celestial mechanics. The apple that reputedly fell from a tree in Woolsthorpe, inspiring his thoughts on gravity, became an iconic symbol of his profound insights. Knighted by Queen and in 1705, Sir Isaac Newton's influence transcended the confines of academia. As Master of the Royal Mint, he applied his meticulous intellect to matters of currency, combating counterfeiting and establishing a legacy that extended beyond scientific realms. Newton's life was a testament to the intricate dance between brilliance and solitude, discipline, and creativity. Behind the stern countenance of a thinker lay a man who grappled with personal challenges and internal conflicts. His eccentricities and bouts of intense focus mirrored the enigma of his genius. Newton passed away on March 31, 1727, leaving an indelible imprint on the scientific landscape. His legacy endures not only in the equations that bear his name but in the very essence of the scientific method. Sir Isaac Newton's life story is a celestial ode to the human spirit's capacity to unravel the mysteries of the universe, a luminous legacy that continues to inspire generations of seekers, dreamers, and lovers of knowledge. Isaac Newton, a brilliant mind from centuries past, uncovered some incredible truths about how the world works. One of his big findings was all about motion, how things move. Imagine you're playing with a ball. Newton figured out that the way the ball moves is because of a force, like when you kick it or throw it. He wrote down 3 simple rules, called the laws of motion, that explain how everything moves around. Another cool thing Newton discovered is all about gravity. You know how when you drop something, it falls to the ground? That's gravity in action. Newton realized that this force doesn't just work on Earth, it reaches out to the moon, the planets, and even the stars. It's what keeps everything in the universe moving in a sort of cosmic dance. Newton also had a play date with light. He found out that if you shine sunlight through a glass prism, it breaks into all the colors of the rainbow. That's why we see rainbows when it rains and the sun comes out. It's nature's way of playing with Newton's discovery. So, in simple words, Newton's discoveries are like the superhero comic book of science. He uncovered the rules that govern how things move and showed us the invisible force that keeps everything connected. His ideas became the foundation for how we understand motion, gravity, and even the colorful magic of light. Thanks to Isaac Newton, the secrets of the universe became a bit less mysterious and a whole lot more fascinating. Isaac Newton is renowned for his groundbreaking contributions to the field of science, particularly in the areas of physics and mathematics. While he is not typically credited with specific inventions in the traditional sense, His revolutionary theories and mathematical frameworks laid the groundwork for a profound understanding of the natural world. Here are some key concepts associated with Newton's contributions. Laws of motion. Newton formulated the three laws of motion, which describe the fundamental principles governing the motion of objects. These laws are the foundation of classical mechanics. Law of universal gravitation. Newton proposed the law of universal gravitation, which states that every mass attracts every other mass in the universe with a force proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law explains why objects fall to the Earth and how celestial bodies, like planets, orbit the Sun. Calculus. Independently of German mathematician Gottfried Wilhelm Leibniz, Newton developed calculus, a mathematical discipline that deals with rates of change and the accumulation of quantities. Calculus is an essential tool in various scientific and engineering fields. Reflecting telescope. Newton designed a type of reflecting telescope, known as the Newtonian telescope. It used a curved mirror to gather and focus light, providing a more compact and less distorted image than traditional refracting telescopes. Binomial theorem. Newton made significant contributions to the development of the binomial theorem, a mathematical formula for expanding powers of binomials. This theorem is widely used in algebra and calculus. While Newton's work was primarily theoretical, his insights and formulations have had a profound and lasting impact on the scientific community. His laws and theories laid the groundwork for centuries of scientific exploration and technological advancements, making him one of the most influential figures in the history of science.